So the enormous advance represented by the completely new design for the contents of the boiler. I mean, that must have made all the difference.
This enabled it really to produce the quantity of steam required. It had about 80% more heating surface than Sons per Eye,
so how did he get that huge increase in heating surface?
He used two ways. Basically, he used a large number of small tubes through the boiler. There were 25 3-inch diameter tubes going right through the boiler, but behind that he had a copper smoke firebox which was jacketed, and that gave him a good heating surface as well. So he was able to generate the steam, which gave him the speed necessary. Yeah.
Because by putting in multi-tubes into the boiler, obviously he was left with the problem of where the fire was going to be in the engine, right?
Yes. The other locomotives, or the other goods locomotives on the Stockton-Darlington line, for example, had a fire within the boiler. Now this couldn't be with a multi-tubular boiler, as was conceived by Stephenson and Booth. So they built on the back of the boiler a jacketed firebox, and this was a separate item on the back.
We tend to think of designers in the modern world as people who are making precision measurements, calculations and so on. It seems to me that the stories we're learning about from your work on the rocket show us that there's a very interesting relationship in Stephenson's system between the ability to calculate inputs and outputs, for example, the amount of coal required to burn, the intensity of the heat and so on, the amount of weight you need on the driving wheels so that you get the proper kind of adhesion, and a sort of aesthetic idea about technological design, which isn't really mathematical. How do you see those factors in Stephenson's designs fitting together, the kind of expert knowledge, which is mathematical and quantitative, and these ideas of judgment about the best way of designing and arranging the components of the system?
It was basically driven by the technology rather than the aesthetics. He was able to calculate the centre of gravity. He knew he needed greater heating surface. Therefore, he designed it around those.
One thing that I think is very striking then is that men like Stephenson have a much more than adequate command over the principles of what was then called mechanical philosophy. I mean, and I think that does help us begin to understand what's special about the British situation, where you have this alliance between engineers and entrepreneurs, both groups of whom certainly understand enough of mechanics, of the physics of friction, for example, really to make some very intelligent design decisions about steam engines and lots of other devices too.
It wasn't just designed to be beautiful, it was designed to work efficiently, and it did.
No.